Let's summarize what we've learned about average and instantaneous velocities. If we have the position of a function given as a function by s equals f of t, so that's the position of an object at time t, then we can compute the average velocity of f on the interval from a to b with the following formula. The average velocity on AB, that's what AV sub A comma B stands for, is computed by computing f of B minus f of A divided by B minus A. So that is our position at the end of our time interval minus the position at the beginning of our time interval divided by the length of our time interval. So this is the change in output in our case, the change in position divided by the change in time. That's how we are computing our average velocity. And as our time interval, so that is the difference between A and B right here, so that is the length of our time interval, we can call that h. As that h, that length of our time interval gets smaller and smaller and smaller, and so as it approaches 0, as h approaches 0, the average velocity approaches the instantaneous velocity of our object just at one moment in time, at t equals a, which was the start of our time interval from before. So we can use average velocities on shorter and shorter and shorter time intervals to approximate instantaneous velocities. Now the units of average and instantaneous velocity are the units of s per unit of t. So the unit of our position divided by units of time. So for example, if s is measured in meters and t is measured in seconds, then the velocity is measured in meters per second. Or we could also write that as meters per second. One more note, the average velocity is just one specific example of an average rate of change of a function. We've seen average rate of change in the previous section, so looking at average velocity, it's just one specific example of an average rate of change where our function happens to give us a position of an object. So in that special case, when we're looking at the position of an object, the average rate of change tells us how fast that object is going, and so that's what we are then computing average velocity. But it's exactly the same idea.